Welcome to Chapter 4, Systems of Equations. Our first section is literally about systems of equations, but that's the underlying theme of the entire chapter. We're going to go in depth and look at different things about systems of equations. Today, I'm going to introduce you to what they are and how to solve them. So let's get into that. So what is a system of equations? Well, a system of equations is a set of equations. Literally, it is multiple equations. So we've seen things where, for instance, we graphed y equals mx plus b. That's an equation. Now I'm going to have multiples of those together. So as we do a system of equations, we're only going to focus, though, on two systems or two equations in this particular section. We're going to skip section 4.2, which deals with more than two equations. But in reality, everything we do in this chapter can apply if you have more than two equations. Same idea, just takes a few more steps. Now, the next one is also, we're only going to focus on linear equations. That means everything we're going to deal with is going to be a straight line. It may be horizontal, it may be vertical, it may be at an angle, but it's only going to be straight lines. We're not going to deal with anything that's a circle or curve. But again, everything we do can be applied to linear systems, nonlinear systems of equations. So keep that in mind, that this can be applied. In fact, it will probably come up later in a future section to point out what something means. But to help you understand it, let's just do an example. So here is a system of equations. 2x minus y equals 4, and x plus y equals 5. So I have these two equations. I want you to pause the video, and I want you to graph both of those lines. Draw each line separately. Go ahead. Welcome back. So you've hopefully now drawn both lines, and you should have gotten these two lines, where the blue line is the top equation, 2x minus y equals 4. And the red line is x plus y equals 5. Now, as you're looking at this graph, notice that my two lines cross right there, the point 3, 2. That literally means that the solution to my system of equations is the point 3, 2. So notice I wasn't just solving for an x, you're actually solving for an x and y, which leads to us understanding what are the possible solutions to a system of equations. This, as I'm going to go through these steps, is critical for understanding and doing well on this concept. So first, we just saw an example where I have a single point. Two lines cross once. This is a very common thing. But is it possible that I have two lines that never cross? There would be no solution. Think about it. What kind of lines never cross? Hopefully you're thinking back and say, oh, wait, we dealt with those. Those are parallel lines. True. So if I have two equations that are parallel, then there's no solution. And I'll show you how to find that later on, but make sure you understand what no solution really means. It means they're parallel. On the other hand, what about infinite solutions? So when do I have two lines that are always crossing each other? Well, hopefully you're saying, well, they have to be the same line, just repeat it. And indeed, that is true. So the three possible options we can get are a single point, no solution, and infinite solution. So these are all the different things that we kind of work through and we use to our advantage. So now that you have what kind of solutions, let's talk about how to check a solution, because that way you can always check your work. So if I have the point 3, negative 2, I want to see if that is the solution to this system of equations. Going back to the very last slide, I said that it's a solution if it's where it crosses. So two lines will cross if and only if that point is on both of the lines. So how can we check if this point, 3, negative 2, is on this line, x plus 2y equals negative 1? Well, we can plug the x and y values in, and then just compute. And you get 3 minus 4 is negative 1, which is true, so we're okay with the first one. And now I want you to check now, is this point on the second line? Pause and go ahead and do that. Okay, hopefully you did it. First thing you did was you inserted the point. Then you got 6 minus 2 is equal to negative 4. That is not true because 6 minus 2 is positive 4. So that's not true, which means our point is not a solution to the system of equations. So we can always check our answer by just plugging it back into the original equations. And piece of advice, we're going to do some manipulation of equations. Please do not ignore checking. It will help you out a lot. So how do you solve? This is probably the big algorithmic. There are many ways to solve. The first and foremost method is graphing, like we just did. You can always graph. And can you think for a moment about what's the benefit? When you pause the video and write down what's the benefit of graphing and what's the downside of graphing. Okay, well, hopefully you thought and said, oh, graphing is a nice visual thing. But what if your two lines cross and they're not on the grid at a perfect integers? So what if my answer has fractions in it or decimals? That makes that even harder to kind of see. So the next option that I see students use is they guess and check. You can guess, but again, going back, how many of you are going to guess if it's a fraction? What if it's not really, most people guess points that are really close to 0. In fact, there's certain numbers that people tend to guess often, 3, 7, 1, and so forth. What if it's not one of those? What if it's like negative 12 and 15? You're not going to know that very well just by the guessing. So again, not a very good option. Checking is good, but do not just guess and check. The third thing that I'm going to talk about is substitution. So we can, and I'll explain what this means. This method is going to be one of the more common methods. And then we're also going to talk about something called elimination or addition method. Now, some of you may have also learned about a fifth method called the matrix method. And yes, that's like the movie because matrices are used by computers all the time. And they're a fundamental part of computer science. So the matrix method, though, is really just the elimination and addition method with some twists added in. So in this class, we're only going to focus on substitution and elimination and addition. So become familiar with them. I'm going to show you how to do them. Become familiar with both of them. I expect you to be able to do both. You may have one that's your strength, and that's okay, but make sure you can do both of them. So let's talk about how to do substitution. So here's my system of equations. Y equals 2x plus 2, and y equals 2x minus 1. Well, substitution means I'm going to swap something in. So notice my second equation, y is equal to 2x minus 1. So I can take that 2x minus 1 and I can substitute it into the other y. Where I see y, I can replace the y with this statement right here. And you get this 2x minus 1 equals x plus 2. Okay, I want you to pause the video and I want you to solve for x. All right, so hopefully you've solved for x, and as you did that, notice I did the steps where I added 1 to both sides, and I subtracted x from both sides, and I get x equals 3. Are we done though? Hopefully you're saying no, because remember, I need a point. So I don't just need x value, I need a y value too. Well, how could you find the y value given that you have x? Again, hopefully you're saying I can just plug it in. Specifically, I could plug it into the first equation. It doesn't matter if you pick the first or the second equation, you'll get the same result. But pick one of the equations and plug in x equals 3. And you do that and you get y equals 5. Well, now I have that, which means the solution is the point 3, 5. It's that simple. Well, let's go to a different one. Again, here's another system. I want you to pause the video and I want you to ask yourself, what can I substitute from one equation into the other equation? Okay, hopefully you said, okay, I have y equals in the second equation, so I can take x minus 2, and I can substitute that in for y in the first equation. So notice I put parentheses around it to make sure I got my signs correct. And I get 3x minus 3, parentheses, x minus 2, instead of y. And and I get a 6. All right, again, pause the video and solve for x. Hopefully, you finish solving for x. As you distributed, notice the x's cancel out because 3x minus 3x is 0. And I just get 6 equals 6. Oh, okay, wait, there's a slight problem here. I have no more x's. Well, that's okay. When you were solving equations as a prerequisite and in the preview, the review material, remember if you got something so that 6 is equal to 6, when is 6 equal to 6? Hopefully you're saying always. Well, since 6 is always 6, there are infinite solutions. Why is that? Remember I said infinite solutions is if it's the same line. So let's look at that first equation. Can you write that first equation, 3x minus 3y equals 6, in slope-intercept form? Pause the video and go ahead and do that. All right, welcome back. Hopefully you did it, and you notice that if I take that first equation, subtract the 3x, divide by -3, I get the exact same equation. So because they're the same equation, that is why there are infinite solutions. So if you think there's infinite solutions, you can always check this very simply in that manner. All right, let's do another example. This one, again, I want you to solve by substitution, but notice I didn't give you something that was y equals, and by the way, it could be x equals in some cases. It's your choice. So because I don't give you that, can you solve one of the equations to be in terms of y equals or x equals? So pick one of the equations and solve for y or x for that equation. Okay, hopefully you've already worked through that. If not, pause and go ahead and finish doing that. So you've done it, and notice if I take the first equation, 6x minus y equals -1, you pick either one, but I like the first one because notice it looks like it's going to be pretty easy to solve for y. So I move the 6x over, I divide by -1, and we get y equals 6x plus 1. Now what can I do with this new equation? Hopefully you're saying I can substitute it in 6x plus 1 for y in the other equation. Okay, I want you to go ahead and pause the video, substitute, and solve the rest of the system of equations. Well, if you do that, you do the substitution, you get this, then we distribute, and be very careful when you're distributing, you got your signs correct. If I combine like terms, I get -24x minus 5 equals -17. Add 5 to both sides. Then I divide by -24. Negative divided by negative is positive, and 12 divided by 24 is a half. So x is 1/2. So if you didn't get that correct, pause, and keep going from here. If you did get it correctly, let's just keep going on. I can substitute that into the other one, and I get 6. And notice, I didn't substitute back into y equals 6x plus 1. I substituted into the original equation. This helps you have fewer issues. So I have 6 times 1/2, which is 3. So then I subtract 3 from both sides. I get -y equals -4. So when you put that all together, you get the point 1/2 and 4. So hopefully you got this idea about how to solve a system of equations by substitution. If it's already given in the form y equals something or x equals something, it's really nice. If not, we do a little bit of manipulation to get it in that form so we can go ahead and solve it. Well, let's move on to the next method that I mentioned, which is elimination or addition. And it literally, as the name sounds, we're going to try to eliminate one of the variables by adding the equations. So if you look at these two equations as they currently stand, can I add them straight down? In other words, can I add this side of the equation together and then this side of the equation together? And if you do that, so I'm just drawing a line underneath, 3x plus -3x is, if you like, 0x. And then I have -5y plus 12y, and that's going to give me 7y. which, notice, gives you 21. So we have this, we plug it in, finish solving, and you get y equals 4. Well, we substitute that back into the other equation, and we get, so we substitute in to solve for x. We get x equals 9. So our point is 9, 4. So let's go on and let's try a different one. Notice this one, I'm going to pause you right now. If I was trying to add these right now, would I eliminate any variables if I added straight down? Hopefully you're saying no, because the x's wouldn't cancel out, the y's wouldn't cancel out. So this will happen, and we can still use the elimination method. We just need to manipulate the equations so that we can add them together. So if you look at that first equation, I'm going to pick x. You can pick whichever variable you want. But notice, if I multiply this thing by 2, this will make this 10x, which when I add down, it will make the x's go away. So I can multiply that whole first equation by 2. But remember, whatever I do, once I have to do the other. So I'm going to multiply that first equation, which gives you 10x minus 14y equals 24. Now I want you to pause the video and I want you to finish going through the elimination process. Can you add the two equations together? So here's what you're adding together. Go ahead and add them. All right. When you add them together, hopefully you realized I got 0 equals 48 because everything on the left-hand side is going to cancel out. And 24 plus 24 is 48. Well, wait a second. Again, there's no x's, there's no y's. How do you keep going forward? When does 0 equal to 48? Hopefully you were saying it never is equal. Well, it's never equal, so there is no solution. And if you were to take a moment and work through this, you'd realize that these equations are parallel lines, but have different y-intercepts. So that's just kind of the overall check. So this one has no solution because they're in parallel lines. Now, you may not know that, and to be honest, trying to put this in slope-intercept form probably be more annoying than just doing this, what we've already done, this, and multiplying the first equation by 2 and then adding them. So there's multiple ways to get at this, but this is understanding what's really going on. So let's do a final example where I'm telling you what to do. I have elimination and addition. So we've already dealt with an example where off the bat I could add them together. One where I can multiply one of the equations and add them together. So the natural linear progression is that this one is going to be one where I have to multiply both equations by something. So look at both equations and say, what can I multiply the first one by, and what can I multiply the second one by? It doesn't have to be the same thing, but to get them to the point in time where I can cancel out one of the variables. Well, hopefully, if you look at it, you say, okay, let's look at the first equation. If I multiply that one by -2, multiply both sides by -2, and you should get -8x minus 10y equals -44. Now I'm going to stop you. Notice if my first equation, so that's the 4x one, is now going to look like this. What can I multiply this thing by so that when I add it to this, it's going to cancel things out? Hopefully you're saying I can multiply by 5. If you multiply the second equation by 5, notice you get 45x plus 10y equals -30. And to help you better see that, let's add them both together. Notice what's going to happen to the y's. Hopefully you're saying they cancel. Good. So I want you to pause the video, finish solving this equation, and remember the final solution is a point, both x and y. Go ahead. Welcome back. Hopefully you realize that as I add it together, let's just go through the steps. When you add them together, you get 37x equals -74. Divide both sides by 37, x is -2. Okay, if not, pause, go back, use that to find the y. If so, let's just go on. So if I plug in -2, you manipulate and you get y equals 6, which means your final point is -2, 6. So this is all these ideas about how you do elimination and substitution. Now we're going to do this, and a really important thing though is not every equation is optimal for one method or the other. You have your favorites. I personally prefer the elimination method, but I recognize there are times when substitution is even faster. So you kind of got to go with your gut and get familiar with them. So the last example we have is this one where I say pick which one you want. So you can use substitution or you can use elimination and addition. And this is going to play a bigger role in the next section where we're going to have systems, and I'm not going to tell you how to solve them. You're going to have one of these two to use. So I want you to pause the video, and I want you to go ahead and solve this by substitution or elimination. Your choice. Welcome back. Let's talk about how to solve these in both methods. I'm going to show you both ways. So suppose you pick substitution. Let's go with that example. So I need to, if I'm doing substitution, I got to get one of them to be y equals or x equals. The first equation, notice is really nice. You can slide everything over and move it so it turns out to be y equals 8x minus 17. And then, so if you're doing substitution, you should have gotten that. If you didn't, pause, go back and use that to substitute. Otherwise, keep going with the video. So if we substitute into the other equation, we plug it in for y. We now distribute and solve. You end up with x equals 3. Are you done? No. So, and you hopefully can go through all these steps. Pause the video if you have to want to look through all the steps to make sure where you went wrong. This is how everything multiplies out and so forth. So x equals 3, I can take that and substitute it back in. But again, I would not substitute in here. I take this and I substitute it back up in this first equation. So if you do that, it turns out you get y equals 7. So my point is 3, 7. So notice it plugged in 24, subtract 24, divide by -1, and voila, we have it. All right, so that is the substitution method. Let's talk about the elimination method. So how would you do this using elimination? Well, remember elimination, I want to multiply one of the equations by, so when I add it to the other, it cancels. I can multiply the first equation by 3. If you do that, you get 24x minus 3y equals 51. Now, add in the second equation. Notice when I add them together, the y's will cancel out, and you end up with 28x equals 84, or x equals 3. All right, so elimination. And if I do that, if I plug that in, now notice it's the same x I got in the previous one, so again, plugging in, you're going to end up with the same exact result. And I already walked you through that, so I'm not going to walk you through it again. But my point is, again, 3, 7. So we get the same exact point, either method. So if you're really good at one method, good, you can use it to check. Do not rely on it. I promise the first exam will have both options. You'll be expected to do both of them. All right, that's the end of section 4.1. Please make sure you do plenty of examples and get very familiar with how to do both methods in order to maximize your ability to succeed.